Neil deGrasse Tyson recently wrote a book called Astrophysics for People in a Hurry, and that gave me an idea. The idea was to steal Neil deGrasse Tyson's idea and to do it for climate science. But Neil deGrasse Tyson's book is still 224 pages long, while this video is only a few minutes long. So this is climate science for people really in a hurry. Now, science has no unquestionable truths, but there are certain aspects of science that have survived so many challenges that they can effectively be considered true beyond any reasonable doubt. One of those aspects of climate science, known about since 1824, is that the Earth has what's known as a greenhouse effect. And all that means is that there's certain gases in the atmosphere that interact with radiation in such a way that it keeps the Earth warmer than it would be otherwise. Now, we've known since the 1860s that certain gases in the atmosphere, like carbon dioxide, methane, and nitrous oxide, are greenhouse gases. And human activities like the burning of fossil fuels, deforestation, and agricultural practices have caused the atmospheric concentrations of these greenhouse gases to spike. Also, beyond reasonable doubt, is that over this time period when greenhouse gases have been increasing, the Earth's temperature has also been increasing. And this is measured by a warming atmosphere, which is measured by a global network of weather stations, as well as weather balloons and satellites. It's measured by a warming ocean, as measured by floats, ships, buoys, and satellites. It's measured by melting ice, so alpine glaciers, sea ice, and the Greenland and Antarctic ice sheets, and it's measured by rising sea level. Furthermore, the amount of warming that we've seen since the Industrial Revolution is roughly in line with what we would expect given the human-produced increases in greenhouse gas concentrations, as well as the human-produced cooling effect from aerosols. Moving on to aspects of the science that are more uncertain but we still have a very high degree of confidence in, we can say that most of the warming since the midpoint of the 20th century has been due to human causes, and the best estimate of how much of the warming has been due to human causes is 100%. We can also say with very high confidence that as humans continue to emit greenhouse gases into the atmosphere, the globe will continue to warm. Most of the uncertainty in how much warming we'll get in the 21st century comes from scenario uncertainty, as in how much greenhouse gases humans will actually emit. But there's also substantial uncertainty in how much warming you get for a given amount of change in greenhouse gases. We also have a high degree of confidence that as the Earth continues to warm, certain types of extreme events like heat waves will continue to get worse, both in length and in terms of their severity. Also, coastal flooding will continue to get worse as sea levels rise. We have less confidence in other types of extreme events like droughts and floods. There's good physical reasons to believe that as the climate gets warmer from greenhouse gas emissions, there'll be less light precipitation and more heavy precipitation, which could make it possible to simultaneously experience more droughts and floods in the same location. But natural variability in these events is quite large compared to any climate change signal, so attribution of these events to climate change remains difficult. The situation is complicated further when we consider that the climate change signal might depend on the time of year or the location, so the same event at a different location or time of year might have a different contribution from climate change. These same type of issues affect our confidence in how climate change might be affecting other relevant weather phenomena like hurricanes or tornadoes. Thus, these are areas of active scientific research. Another area of active research is how climate change will affect ecosystems, and there's significant concern that many ecosystems will experience increased rates of extinction primarily because the climate is moving away from the ecosystem faster than the ecosystem can migrate. Finally, there's a great deal of speculation about how climate change might affect other relevant aspects of our future. Unfortunately, we have much less confidence in the most policy-relevant questions. So just to take an example, there's been speculation that refugees might increase in the future due to climate change. Now we can think about this in terms of an equation. So one way to think about it is that we're trying to quantify a change in refugees from a country per the change in CO2 emissions. So we can think about this as being equal to the change in CO2 concentrations in the atmosphere per the change in CO2 emissions from human burning of fossil fuels. That has an uncertainty associated with the carbon cycle. And then that would be multiplied by the change in global temperature per the change in CO2 concentrations. That has an uncertainty with it that we refer to as climate sensitivity uncertainty. And that would be multiplied by the change in some relevant weather phenomena in that country, like the drought severity per the change in global temperature. We already talked about that there's an uncertainty associated with that. And then we would be multiplying that by the change in economic losses per the change in drought severity, and then the change in refugees from the country per the change in economic losses. So you can imagine that all these terms have their own uncertainties, and the uncertainties become extremely large on the right-hand side of the equation, where you're moving away from a physical system into a socioeconomic system. So all of these uncertainties compound and make it almost impossible to actually quantify your original thing that you want to quantify. So we're stuck with making decisions under deep uncertainty. And that's climate science for people really in a hurry.